For anyone just entering, thanks again for joining us today. We appreciate it. Let us know where you're joining from, and I'll turn it over to Mr. Bruce Prowl at this time, and he'll present. Thank you.
Thank you, Heather, and welcome everyone. My name is Bruce Kroll. I'm an encapsulation specialist for hazard control technologies. I spent a little bit more than 36 years with the fire service in Colorado. I was the fire marshal there and an ICC certified fire marshal, fire plans examiner, fire inspector, a SIPC designated fire marshal for a Class 1 accredited fire department. So I've been around the service for a little while, but now I am with Hazard Control Technologies to talk to you about encapsulating technologies and how that will help you wherever you are in the lithium battery life cycle. So Hazard Control Technologies has been around for 29 years. They've been interacting, testing, and being applied to the battery industry for 17 years and over 6 continents. Tested, used, designed in all those continents. So it's been around a while. The product's been around a while. So the company and the people there know a lot about interacting with lithium-ion batteries and the multiple other hazards that encapsulation technology is applied to. So today we're going to talk about specifically the hazards involved in the whole chain of lithium-ion battery life. Starting from that sort of upper left there where it actually gets mined out of the ground. A lot of international tension, politics, negotiating about where those minerals come from, a lot of science around alternatives, different kinds of components, and all that involved with just getting the products to make the batteries. Then those products are refined. Then the cathode production is put together based on the materials that were refined and mined. Then battery manufacturing. So battery manufacturing involves all the steps of that, whether it's creating a cell, putting the cells into modules, putting the modules into the equipment, vehicles, tools, whatever that battery is going to go in. It also includes the testing, destructive testing, improvements that go along with the whole manufacturing as it exists today. From one day to the next, the batteries are evolving. Then the batteries get applied in some sort of equipment, whether that's a vehicle, truck, forklift, power tool, surgical equipment, you name it, it's there. So then the battery spends its life until it is no longer providing the output that's needed or otherwise considered unreliable, damaged, end of use. Goes to a few different places at that point, at least now. You know, this technology could evolve even more for the life cycle of a lithium-ion battery. But it could go to the direct recycling where a hydro process or a pyro heat process extracts the materials, separates the materials so they can be recycled and built into new batteries. Batteries can also be left intact and sent to a different use where I'll cover later, where old batteries are still being used to store energy. And it's pretty amazing technology. And at some point, those materials are no longer of use or they have been not recycled and they're just put in a landfill. So let's talk a little bit about hazards and what we can do about that along the way. So lithium-ion battery is a rechargeable battery. You know, that sounds obvious to us these days, but it wasn't that long ago where there was no such thing as a rechargeable battery. Lithium provides the high density energy where it makes it actually practical to use. There's 3 major layers, the anode, the negative side, the cathode, the positive side, and the solid electrolyte interface in between, allowing the movement of the ions. So that solid electrolyte interface was something that was developed over a lot of years and almost discovered by accident, but it's a layer that forms on the anode surface that helps provide a barrier that makes the battery function to a higher degree of efficiency, up to 99%. And it also helps the battery have a longer life and not subject to recharge degradation. So during the initial manufacture of the battery, the first charging cycles start to form. The electrolyte decomposes and forms on the anode. It is an important part of how the battery functions and also a place where battery failure can occur. So let's talk about that a little bit. So when allowing the passage of the electron, a well-formed, stable SEI is crucial for the long-term function of the battery. It also prevents internal short circuits and internal runaway. So in forming that stable SEI layer, you can't go too quickly in manufacturing the battery, which was found out the hard way as battery demand skyrocketed. It was helpful to build the battery as fast as you could. It helped you compete. Well, if you form that SEI layer too quickly, you don't let it form the way it naturally would, you get dendrites, which are long fingers of material that actually can go across the SEI membrane and short circuit the battery and make it fail. And fail sounds benign. It makes it short circuit, explode, put off the toxic gases, all the things that a lithium ion battery failure produces. So the different ways a lithium ion battery can fail, just in short, you have the short circuiting, whether you have an unstable battery that was produced. Anybody that's in the manufacturing industry, they usually have an area in the facility for batteries that failed or are failing in order to deal with that off-gassing, overheating, and other complications of a short-circuiting, failing, newly produced lithium battery. Then through the whole process, the battery and their components, whether it's the cells, the modules, or the finished product, gets moved around a lot. It can be dropped, damaged, hit with a forklift, subjected to a fire from another cause, salt water from floods, storms, hurricanes, all kinds of trauma that makes that battery fail. Overcharging gets a lot of attention. A lot of EV car fires occur because of overcharging, and that's some failure in the equipment that recognizes the battery is at full charge and or fails to shut off the charging mechanism. And then extreme temperatures can have an impact. Cold can cause the battery not to function properly. Overheating can cause internal failures to the battery module itself. So kind of point that out. I have a picture here of a battery cylinder being unrolled, and it gives you an idea of how close together the anode and cathode are. It's almost like three pieces of paper. So it doesn't take much to poke a hole in that or crinkle it or somehow make the anode touch the cathode, and then the battery overheats and fails and or explodes. So, we're not dealing with something that's really robust in its basic form. It's that sheet of paper gets rolled into a tube called a cell. The cell gets multiplied into a module, providing many, many opportunities for failure. So once that failure occurs and the overheating takes on a life of its own called thermal runaway, that can occur in two different phases at least. One is the non-burning phase. I'm going to show you a video here. What I want you to pay attention to is how much vapor and material is coming off of that battery. And the two things that we're most concerned about with that failure is the explosive vapors, the hydrogen ions that are ready to combine and or explode, and then the toxic components of that vapor, hydrogen fluoride being the worst, but there's many more in there. So that failure, even though it's not burning, you're building up vapors to an explosive level, or you're creating toxins um, in a high volume. So let's take a look. You can imagine if this was in a 20 by 20 room or any sort of confined area, the room would be filled by now, top to bottom, with those vapors. So anything we can do to prevent that from happening and or controlling the explosive and toxic vapors as they are released from the battery is what we're looking for. And then we go into a battery that all those explosive vapors ignite on the way out of the battery compartment. And there you have the obvious heat and flame contact, shrapnel, pieces and parts, and then exposure to whatever's next to the battery, including additional battery. So again, we're looking at the vapor cloud and its toxins and explosive nature, the blowtorch flame, projectiles, and then the spread of fire to who knows what. So how much batteries are out there? Right now, countries all over the world producing their own versions. There's not like an international standard for what that is. The gigawatt hours are growing exponentially. Top producers, some bigger laboratories and manufacturers, but there are many, many smaller ones, all subject to varying forms or no forms of regulation and standards. So what shows up at your doorstep could come from anywhere. So the amount of batteries that go into recycling, you can see the change from the year 2020 to 2025 and the projected. So for those of you that weren't familiar with a metric ton is 1,000 kilograms, which is about 2,200 pounds. So it's a little bit bigger than an English ton. So that is a lot of material going into the recycling process. But the benefits of that, when it goes well, you can recover 95% of the materials used in the formation of the battery to begin with, including all those rare earth minerals, which then that helps create new batteries, reduces how many of the battery parts are in the environment, in the ground, and decreases the reliance on finding more rare earth minerals. So recycling is an important part of the world economy and the world ecology. But you're obviously dealing with a hazardous product. So here's a short video of a fire in a recycling plant in Missouri. There's fire. So you can see, I mean, there's other products of combustion there, but a lot of those are the explosive vapors coming from the batteries as part of the recycling. And once you get enough of those vapors that come in contact with the fire,
boom! I got it.
So again, still lots and lots of toxic vapors coming off of that.
All right.
So this fire occurred in October of 2024. By May 2025, the facility collapsed, fell apart, affecting the local economy. There's going to be big expenses in cleaning up the site, I'm sure, as the echo people go in and start testing the ground and the materials there. So it's a huge impact on that local economy and the jobs that are lost in the process. And then, you know, the recycling need doesn't stop. So where all that material that used to go there has to go somewhere else. So the benefit of preventing this sort of catastrophe is on many levels, whether it's a local economy, jobs, contamination of the environment. and the economy of the business. So just at recycling facilities, as we go into the secondary use and the after it's gone through its primary use, the battery again goes into the recycling world. So there's hundreds of recycling incidents, and some of those are battery-specific recycling facilities, and some of those are recycling facilities that happen to get batteries in them. Either way, we got multiple hazards along with the toxins involved. So since 2021 alone, there's been over 20% increase in the incidents occurring in recycling. And you can imagine if you extrapolate that out in the future, we got to get ahead of this. So here's a little bit of information, a video on a facility that is reusing the batteries, and I'll let them explain some and then I'll go over it.
With more electric cars on the road every day, some people are wondering what will happen with the growing number of retired batteries.
A local company is now leading the charge on providing a second life for those batteries. CBS 8's Evan Nurani took us to their launch in this Earth 8 report.
It's only been a month since an unprecedented heat wave hit California, renewing the concerns of power blackouts and brownouts. But one San Diego-based company is helping bring a long-anticipated process to life, providing battery-stored renewable energy to the grid.
This has been the goal from day one, to be able to better use second life batteries, reduce emissions, and bring a cleaner future along with U.S. domestic manufacturing to the United States and to San Diego.
Smartville is repurposing Nissan and Tesla electric vehicle batteries by storing solar power from the roof of a building in Miramar. The batteries can hold enough solar energy to power the building for 48 hours, reducing California's dependence on the grid.
We're now getting 18% of new vehicle sales in California are electric vehicles, and that number is rising. We're putting almost 1,000 electric vehicles a day on the road in California, and we're manufacturing over 2,000 electric vehicles a day here in our state. So this is filling a very important kind of hole in the mosaic.
Adding one and one together, we see a large supply flow of retired batteries. To give you an idea, nationwide by 2030, we have about the annual supply of 100 gigawatt hour worth of batteries. Those can be put in good place to providing residual values, such as stabilize the grid and provide business the energy storage they need.
California has more registered electric vehicles than any other state, and batteries need to be replaced if they're not at peak performance due to normal wear and tear. But those batteries can still function at a good level before being recycled.
That battery can still be used for a long time. And so what we do, instead of recycling the battery, instead of throwing it away, we're using that battery and we're using it to provide a service. We are harvesting excess green solar energy and putting it on the grid to reduce emissions and to help stabilize the grid.
With a successful launch in the bag, Smartville hopes to fully commercialize that process in the next year across the state and eventually across the nation.
Eventually, with the EV adoptions goes beyond California, we have East Coast, we have Pacific Northwest. We're going to set up posts for repurposing those batteries and providing energy storage in return.
The process not only provides a smarter option for the batteries before recycling, but also helps put less stress on the grid. In Miramar, Evan Nurani, CBS 8.
So there are several of these facilities out there in the United States already. Those were shown in cabinets up next to some sort of a building. And I've seen some that they're just out in a large yard in certain divided up piles, for lack of a better word. But it's a remarkable use of a battery that, for whatever reason, got taken out of the use, whether it was no longer charging the way it was supposed to, or a certain amount of time it was figured it should be taken out, but there's still charging capability. And it can be put in a facility like this that if one battery fails or a cabinet of battery fails, since you're storing energy for later use, it's not quite the catastrophe to the operation that a battery being used for equipment would be. But you still have those hazards with the explosions and toxic gases. And if they're in more remote areas where a lot of battery solar type facilities are, the emergency response is limited compared to a large city. So the amount of water, people, and intervention that's available is limited as well. So its secondary use is battery emergency backup power, stabilizing the grid for the high points and low points in the daily use of an electrical system, or a system that depends on some sort of renewable energy when there's cloudy days or less windy days and you need to draw stored energy. These secondary life uses become valuable. And they can power smaller devices as opposed to large vehicles that travel around a lot. So like I said, the pros, I guess there's a new line of employment, a recycling industry boost, zero waste concept, hopefully less mineral demands and less ecological impact. The cons, limited standards, like a lot of things in this battery industry, the standards just, at least in America, they can't keep up. So as soon as standards start to come together, there's something new that comes along, and then do you grandfather, and we'll talk about that a little bit later. It's a challenging process to recover those batteries in a safe manner, transport them to the site, hook them up, and not have some sort of failure. Can be expensive. It is hazardous dealing with used batteries that you don't know how they've been handled previously. Reliability, unproven just because it's new. And the stability, again, because it's new. So like I mentioned, the codes and standards for this whole battery life cycle, it's a lot to address when you're talking about the entire life cycle of a battery. And NFPA can address some of the fire hazards, and they're working on it. A lot of people in NFPA working on it. And as you can see, 855 and 800, 855 for the actual energy storage system, frequently a BESS system. Provides minimum requirements for mitigating the hazards. And then NFPA 800 is moving along. The first public input has been closed, but there'll be more. And again, just even in that time, the whole battery process is evolving, the chemicals are evolving. And with the development of those standards, if you look at the battery safety code, there's millions of battery uses that are, I wouldn't say unregulated, but not regulated to that standard. And once this standard does come into place, do you try and reach back into history and change what's already in place? UL 9540 and UL 9540A, which is a evaluation criteria. It's not necessarily a construction criteria. It tells you, is the incident going to spread beyond the cell or the module or the actual enclosure, and gives you an idea of the level of hazard you're dealing with. And that can include fire extinguishment type mechanisms as part of that confining of the fire. And then most recently, ISO, the International Organization of Standardization. I know that's not the right order for the letters, but that must be because it's international. Has come up with a classification L, and I'll go over that here in just a second. The other kind of code and standard that we found a lot and where F500 gets used a lot is in the industry specific, irregardless of the standards, we need to protect our manufacturing process. And that involves a lot of FM testing and evaluation. So there's a lot going on out there and how to control the risks associated with the batteries and always trying to catch up. Even NFPA is saying in the process that are going to rely heavily on researchers and universities around the world. And that's what Hazard Control Technologies and F500 has done, is testing as far away as China, Madrid, Spain, Central America, South America. It's being tested and experimented with and implemented all over the world. And NFPA realizes that's where a lot of design information is going to come from. So at least for now, NFPA envisions trying to give people the tools they need based on research and to understand their options, as opposed to, at least at this point, a prescriptive if this then that. Also a lot of reliance on the phrase equivalency, and that's there for a reason when technology outpaces a standard or code. So that International Organization for Standardization just identifies that Class L is more than A, B, C, D, not sure what F is, or K. And goes into a little bit more detail in 5.7, discussing the cascading thermal runaway and the products of runaway, including heat and toxic gases, and what to do about that. So that brings me to F500 and encapsulating agents in general. I'm going to show you a brief video here about how an encapsulating agent works and then discuss it.
Encapsulator technology, the next generation of fire and hazard mitigation. First, we start with a simplified version of a single encapsulator agent molecule consisting of a hydrophilic polar head which loves water, dissolves in water, and a hydrophobic nonpolar tail which fears water and will do anything to get away from water. Once the EA molecules enter the water, they instantaneously and automatically orient with the nonpolar tails inward and the polar heads outward, forming millions of spherical micelles. Micelles travel towards and exit the nozzles, forming EA droplets. Micelles nearest to the surface of each droplet automatically break apart. The nonpolar tails orient outside the droplet with polar heads on the surface, forming an EA skin on the surface of every droplet. In addition to the EA skin, there are millions of molecular spherical micelles within each droplet.
So what you're looking at here is a droplet of water with F500 molecules in it. So inside the water droplet, those little white balls, those are those micelles. Micelles is a technology that's been used for decades in cleaning agents, skin care agents. It's even used in cancer treatments to deliver cancer treatments directly to the cancer cells. So this technology has been around a long time. Then on the outside of the water droplet, you'll see the F500 molecules have reverse direction and the tails are out. So that provides a way for the water droplet to deliver F500 to the battery components and then reformulate around the ions that are produced from a burning battery. So what is an encapsulating agent? NFPA 18A section 7.7 describes the test for determining whether or not an agent is an encapsulator agent. And it goes through a process of mixing fuel and water and the encapsulating agent and making sure that it cannot be relit, and then sitting for 2 hours and making sure that the micelles have stabilized and will not reignite. So Annex 4.3 in 18A, the explanatory material, goes over the 17-year extensive third-party testing documenting lithium-ion battery fire suppression, as well as the encapsulation of flammable electrolytes and flammable liquids. And like I said, the test itself demonstrates the ability to stop the thermal runaway propagation. And that's a important terminology there. Thermal runaway, once it starts in a battery cell, so far hasn't been able to be stopped. So what the intervention needs to do is trying to stop that thermal runaway from propagating to neighboring cells. So F500 continues to be tested by new entities around the world in battery fire mitigation, consistently outperforming water and water mist.
When fire breaks out, every second matters. On January 30th, 2026, at a recycling facility in Des Moines, Iowa, a routine afternoon quickly turned into a critical moment. Inside the warehouse, temperatures hovered at minus 18 degrees Celsius, minus 1 degree Fahrenheit. And hidden among a pile of cardboard, danger was already building. A front-end loader unknowingly ruptured a lithium-ion battery. Within minutes, surrounding cardboard ignited. The operator had already stepped away, unaware that a fire had started behind them. But the flames didn't go unnoticed for long. Scylla cameras detected open flame. SaferWatch analyzed the video and alerted the Des Moines Fire Department within 4 minutes. At the same time, employees took immediate action, deploying F500EA fire extinguishers and F500EA QAMU units flowing at 3%. Within the first few minutes, employees successfully knocked the fire down, preventing escalation. When the Des Moines Fire Department arrived, just 8 minutes after the alert, the incident was already under control. The result? Minimal damage, no injuries, and a potentially devastating lithium-ion battery fire stopped in its tracks. This is F500EA, proven performance when it matters most.
So something I wanted to point out here, a couple things actually. So this is a multi-material recycling facility, a lot of paper type products. So this is not battery specific. So you have multiple types of material burning here, and in particular on the steel supports for the building itself. So this is a significant hazard that evolved quickly, in which water would not be your primary use because of the multiple different materials and the inability of water to control the gases that are produced. And this probably isn't something you want to have people in breathing. So an overall system is something recycling facilities need to consider for the safety of their people and the continuation of their operation. So let's compare a little bit of agents. So clean agents like halon, those get used in the more technical areas, sophisticated areas of electronics. It can only be discharged once, and if the situation isn't resolved, you don't have more that you can apply. It only addresses the flammable hazard, not the gases, and in fact, it adds more toxic nature to the environment by eliminating the oxygen. It's only effective in an enclosed environment where the clean agent can be retained, and you can't have people in that environment. Water can be used as a continuous discharge. Again, it only addresses the flammable part of the situation. It is effective whether it's enclosed or not and safe to discharge around people. Just by adding 3% of F500 to the water, you get the benefits of the water to a much larger degree, and it also addresses the toxic and exposure vapors. The F500 can be applied through small fire extinguisher type devices for incipient fires only, up to larger equipment for larger high-risk fires or larger vehicles like forklifts, all the way up to an all-encompassing fixed fire protection system, either using a new installation of sprinkler piping or an existing sprinkler system where F500 can be incorporated into the flow of the water. The way F500 gets in the stream of water on a riser and a sprinkler system is through a diamond doser. It's a mechanical pump proportioner, delivering a precise 3% concentration on the discharge of the water F500 mixture. So this gets put in the system. It's driven by water, so there's no electrical need. When you're servicing the fire protection sprinkler system on an annual basis, there's a bypass valve so you don't discharge F500 unnecessarily. And then we can apply F500 through a mist. If there are sensitive electronic materials or other materials where you don't have as much water, mist is a extremely efficient way of applying F500. Again, you're not trying to beat the fire to death with a column of water. You're interacting with the molecules of the fuel. That's an important distinction. You're interacting with the molecules of the fuel and the products of combustion by encapsulating those molecules in spherical micelles. It's a different way of fighting fire, but putting it through a mist application, whether it's low pressure or high pressure, is an extremely efficient way of using the water and the F500. So those are the attributes, whether it's the endothermic process, the water requirement, environment, and economics. So one of the benefits of the F500 is you're creating 60% less runoff. With water mist, it's even less. And that runoff from the water after being applied to a battery fire is toxic and contaminated. You also get the conversion of heat 10 times faster while you're encapsulating the toxins and impurities in the smoke, soot, and runoff, which then prevents the cleanup headaches that you have afterward or significantly reduces them. So by applying an encapsulator agent, you can do a multi-class fire and recycling facility. That's a significant need. Three-dimensional fires that may be running off, dripping off other than a pool. Foam won't address that. Foam isn't the extinguishing agent of choice. You also add the vapor control, whether that's toxic or explosive, and you reduce or eliminate the contamination. That reduces the environmental impact and the costly disposal fees that occur after an incident, and minimal maintenance in order to have a encapsulating agent or F500 or micelle mist system. So another component to now addressing an incident in a recycling facility or a manufacturing facility, the quicker you detect what's going on and where, the smaller the incident will be. That means you have less of your process that's interrupted and less vapors and gases and less environmental impact. So SmartLX is one of the detection processes we use by embedded logic. It can use video, heat detection, infrared detection, audio, detection. It can tell whoever's monitoring the systems what's going on and where. It can even be transmitted to iPhones, cell phones, iPads, tablet devices. So it's very mobile. Not that everyone wants to have to monitor that from home, but if that works for you, you can get it at home. So this intelligent detection system has a lot of applications for rapid detection and efficient response, and notifying whoever needs to be notified, the scale and location of what's going on. So when you put it all together, you can confine battery energy storage or a compartment that has reuse batteries, a recycling facility, manufacturing facility where you can get 24/7 monitoring, gas vapor detection, targeted fire suppression through an NFPA compliant device setup, construction layout, preventing explosions, interrupting thermal runaway propagation. And if you get one of the systems that we put together, no additional cost for the F500 EA and minimal residue after the fact. So putting it all together, wherever you are in the life cycle of the battery, whether you're manufacturing the initial cells and modules, whether you're installing those modules into equipment, tools, scientific devices, whether you're in a data center, a renewable energy electrical storage facility, any place you can imagine those batteries going through, even golf carts, and anything like that for its use. Or after the battery's being used, whether it's being reused, broken down and recycled, or put into a long-term disposal area, you need some sort of way to address that keeps you ahead of the standards producing process, the codes producing process. An F500 encapsulating agent is one of those phenomenal mechanisms to do that, with early detection, application, saving lives and property in your operation. So before I get to the questions, upcoming, again, to show the various ways that F500 encapsulating agent can be used in the whole MyCell science, addresses the fire risks throughout the country, whether that's in March, the fire protection, explosion prevention, and oil and gas, aircraft rescue firefighting, disaster preparation. We have those upcoming webinars. Please sign up to learn more. You also can visit our website at hct-world.com and go through the many different applications. So with that, Heather, do we have any questions in the chat here?
I'm not seeing any questions in the chat just yet. So if anybody wants to ask any questions to Bruce, feel free to either use the chat, use the Q&A box.
Okay. I see some questions here. Are those the same questions you're seeing, Heather?
Yes.
Okay. Well, thanks, Fernando, for the F.
So we have a few in the chat as well as the Q&A box.
Let's see, one of them is, are there other detection methods like gas detection? There is. Basically, any detection method that the manufacturing process would be best served by can actuate an encapsulating agent system, whether that's water added to the sprinkler system or a mist system. Do second life batteries have a higher chance of runaway versus first life? You know, that's a good question. I think that's probably why it's sort of undetermined at this point. I mean, you can imagine that second life batteries have been handled more. They've been installed, used, and then removed and transported. And so just the normal wear and tear on the battery would seem to make it more likely to have a runaway. Though, with a battery in its second use, has less energy density, which is why it was taken out of service. So the amount of power inside the battery, if and when it fails, is somewhat less. So somewhere in the balance, maybe it's more likely to fail, but the failure might be less dramatic. So detection for thermal runaway, whether it's gas detection. Yeah, there's various ways to detect a thermal runaway, whether that's a heat detector, a infrared camera type detector, toxic gas emissions, or smoke. So there are several ways to detect that thermal runaway is initiated. So are there any specific listing or approval agent for UL or FM? So the F500 itself, I can't speak for any other agent, is UL listed for Class A and Class B. And right now, UL considers a battery Class A since there's no other classification. FM, there are a lot of FM approvals for F500 installations, but those are manufacturer specific, where we worked with FM in testing a solution that the manufacturer wanted to use. And that's common in FM applications. But those are all non-disclosure agreements because the manufacturers don't want to give away their protection secrets. The biodegradable factor is important if there is F500 that's been discharged. The Environmental Protection Agency lists F500 as a surface washing agent, so it's actually used to clean up a spill. It's made of biodegradable products, basically fat or lipids and salts. So itself is an environmentally safe product, also as determined by EPA. And the cancer prevention, again, that's kind of a firefighter related thing, or firefighters or anybody else that's around the products of combustion. Because those products of combustion are being encapsulated, you're preventing cancerous agents from forming, and the ones that form aren't getting on the firefighters or their gear because they're encapsulated within F500 molecules. Yeah, lithium-ion batteries don't necessarily contain lithium metal components. It's the lithium-ion and there is a distinction between the two. The lithium ions doesn't necessarily mean it's metal that's in it. Does F500 actually stop thermal runaway once it's started? No, it doesn't. But what it does is reduce the heat dramatically coming off of the thermal runaway in that cell, preventing it from spreading to other cells. That's why I made that distinction between runaway and propagation from cell to cell. So the F500 application stops the runaway from spreading to other cells. But once thermal runaway starts within a battery, that's it for that cell. The video will be available, as all of our webinars are, on our website. Any comments on storage of F500 in foam tanks on fire vehicles? Many fire departments store the F500 in their foam tank pre-mixed. And that will last 5 years once it's mixed with water. If you use the F500 in a foam proportioner that's already on the rig, you need to follow the manufacturer's instructions on keeping that proportioner rinsed. F500 doesn't interact with bronze, but it can have some reaction with brass. So if you just keep it rinsed like the manufacturer says, you won't have a problem. But many fire departments keep the F500 in the tank on their vehicle for immediate use. Is F500 available in other countries? It's available in hundreds of countries all over the world in all 6 continents. Do I see UL adopting Class L and certifying a suppressant agent? Now that's sort of personal opinion. I would think so. It's definitely unique. And you kind of need that in order to start to developing standards around it. But whether they will or not, they're for good or for bad, their UL process is lengthy and very detail oriented, and a lot of testing and retesting before they put something out. But yeah, it's sort of up to UL if that's the route they go. But lithium-ion batteries are definitely their own animal. All right, that's all the questions I see in the question and answer. Thank you for those questions. I appreciate the ability to talk about it. Another question about put F500 in the foam tank and replace it with foam and use it on fires, batteries not. Can you put F500 in the foam tank and replace it with foam? There are many agencies that are replacing foam with F500, especially the ones that have been working with the non-fluorine foams and having frustrations with that. So yes, you can. And use it on batteries. And if you want to put foam back into it, again, just use the manufacturer's recommendation for rinsing the F500 out of it and putting the foam concentrate in if something you want to use foam for. So trying to decipher that question a little bit. Yes, you can replace the foam with F500 and vice versa. Though F500, like foam, requires some training, and there are classes, or I can meet with anyone and go over a presentation on how you use F500 in cases where you would have used foam. So it does require knowledge, training, and correct application. All right, Heather, I don't see any other questions in the Q&A. Oh, there's one. Where can you request the extra training? Just by going to our website, you can request it. And does F500 clog up after long periods like foam? No, it does not. We've had foam in our testing shelves for better part of 20 years, and we don't see any clogging like foam did. Does F500 help prevent freezing of the water in fire suppression tanks? No, it doesn't, but F500 can be mixed to a 50% solution of antifreeze, and it won't affect the performance of the F500. But the F500 itself does not affect the freezing temperature of water. All right, well, I don't see any other questions. Thank you everyone for joining me in this conversation about lithium-ion battery and their life cycle and how F500 and its application can help you. Again, if you have any other questions or would like more training, you can go to hct-world.com, look over the materials, and you can request further training, whether that's an on-site workshop or whether a Teams meeting. We're glad to do either one and help you learn more about F500 and its use. Thank you.